Okay, hello everyone. So now I'm going to go through question 11 from exercise 3b, Arithmetic Sequences. An arithmetic sequence is given by k plus 1, that's the first term. This is the second term, third term, and it appears, yep, that's the final term. So they're kind enough to give us the first and the last term. Find the number of terms in the in the series in terms of k. Okay, well, let's just list out, I like it clear in my mind what information they've given me. Well, they've given me my first term, so I know that a equals k add 1. The difference, well, how am I getting from my first to my second term? Well, I'm adding k, add 2. Let's double check, is that going to work for that one? Add k, add 2, yep. So my difference in terms of k is k add 2. And then they've been kind enough to give us our last term as well. So I know the last term is 303. Right, let's think about what they're saying now. So find the number of terms in the series in terms of k. Okay, no pun intended. So if I think about it, I'm going to use the formula un. So this is the term in my sequence, is equal to the first term, a, add the position, take away 1, times my difference. And just because they've given me the value of the last term, I might as well do that one. So I'm going to say that the number of terms in the sequence in terms of k. So my nth term is 303 equals a, which is k add 1, add n minus 1. You have to be really careful because sometimes you're adding and sometimes you're multiplying in this, and a common mistake is to, as I make as well, is to add when you should multiply or vice versa. So just be really careful with it. This is my a, yep, that makes sense. Then n, my term, or my position, apologies, take away 1 times the difference, which is k add 2. Find the number of terms. The number of terms is basically n. That tells me how many terms are in my sequence. Yeah, so find the number of terms. Well, think about it. The reason I've chosen 303 is because that is, whatever number this is, n, is the number of terms in my sequence because this is the final term in my sequence. So 303 equals k add 1. Add n times k is kn, n times 2, 2n, minus k, minus 2. Simplify. Well, my k and my k are going to cancel. Nice, so I've just got kn, add 2n, 1 take away 2 is minus 1. 304. is therefore equal to, is n that I'm after, and I've made a mistake there, sorry, that should be kn. Let me make that clearer. I should have simplified, I've dropped off the n there, apologies, so it should have been kn, add 2n, and then 1 take away 2 is minus 1. I've then added the 1 on that side, and that's going to give me kn, add 2n, 304 equals factorised, because I want to get n. And I know it's going to be in terms of k equals k plus 2. Therefore, the number of terms in my sequence is 304 over k02, k add 2. Yeah, I don't know how many terms there are in my sequence exactly, but I know that k add 2 in terms of k, because it even says that this is it in terms of k. Right, show that the sum, so that's part A. In fact, let's make all of that smaller. And then I'm going to do question B over here. So that's part A. So part B. Show that the sum of the series. Okay, so we've got two formulas for the sum of our series. We either have Sn equals n over 2 times 2 lots of my first term, add n minus 1 multiplied by the difference d, or much simpler one is n over 2 multiplied by my first term, add my last term. Now I think I probably could use both of these. I could use both of these, but this one, because they give me the last term, I'm going to use this one. So this is the one I'm going to choose to use, and because it's smaller, it should be simpler. One hopes. Yeah. So right, the sum to n terms. So show that the sum of the series, so the sum of all of it, and I'm just going to call it the sum of n because I don't know how many terms is in there, is equal to n, which I just worked out is 304, over k add 2. Then that's all being divided by 2. Now this is a messy way to write it, so instead I'm going to write it as, instead of dividing by a half, dividing by 2, I'm going to multiply by a half. Yeah, so that's my n over 2. Just put that in a bracket. Then that's being multiplied by a. What was a again? K add 1. Add my last term, which is 303. Right, let's simplify this up. 304 divided by 2 is 152 over k add 2. Multiplied by k add 1 add 303. Well, 1 add 303 is k add 304. Then if I expanded that, 152 times k, remember this is the same as, I could say that's the same as a fraction over 1. 152 times k is 152k. Add 46208. K add 2 times 1 would just be k add 2. So, done. Done. Given that, so that's part B. And then let's do part C here. Given that the sum to the nth term, i.e. all of them, is equal to 2568, find the value of k. So, what am I thinking? I'm thinking, well, I know that the sum of n is equal to sorry, I lost track a little bit there. 2568 tells us that. Okay, right. And I'm going to use the Sn is equal to, because I've also just worked out that I've worked out an expression for that, and I know that that's equal to 2568. So I'm just going to equate them. So 2568 is equal to 152k add 46208 over k add 2. So let's multiply that by that. So you should have got 2568 multiplied by k add 2. K add 2 equals 152k plus 46208. So expand, collect the k's on one side, and you should have got that k was equal to 17. Yeah, so expand this, collect all the k's, equate it to a number, and you should have solved to get that k equals 17. Done. Please keep the questions coming through. Keep up the hard work. We're in the final stretch now. All the hard work we do now will pay off when it comes to year 13. Bye.